Get on.
So yeah, we're going to do essentially the same problem again in horrible, and we are dealing with is essentially a block now resting on the table instead of an inclined plane, and the rest more or less remains the same. The table is, in contrast to the problem with the inclined plane, now coming with a coefficient of friction is equal to mu. That is why I said it's coming in horrible. And you know the masses of these blocks. And the big question now is, how big does a block have to be that I super glue on top of the other block in order to prevent the entire system from slipping? Since you already saw how you solve that with help of body diagrams, who's gonna tell me what we're gonna do with that block? What force is acting on it?
We've got gravity going down. And
How much gravity is pulling it down?
MBG.
Is that coming with a plus or a minus?
Oh.
Who says plus? Who says minus? Who says it doesn't matter?
Doesn't matter.
You're completely right. It's purely conventional, right? We only have to be consistent in between the forces that we set up. So the overall sign doesn't change, doesn't matter. We just need to be consistent in our notation. So we have to come with a plus. Yeah. Luther, you were saying how we continue?
Okay, and tension going up.
Right. Tension is being going up. All the forces acting on that block? Yeah. Now we can go ahead and do the second one. So that was for block B. Now we can do block A and see. That is actually not that good an call them both B. What's the force acting?
Tension.
Right, so the string tension. Right. What else?
Weight of block A.
Right, gravity, right. What's the gravitational force pulling down?
Sorry, what?
What's the gravitational force pulling down the magnitude?
Oh, MAG.
MA? Is that all? I mean, we super glue
Oh,
another
yeah,
block.
you have to take into consideration the normal force of the upper block too.
So the entire gravitational force is?
You want to write the total force in the vertical or the?
I mean, acting on the entire system of these two blocks.
Okay, so MA plus MC.
So the entire thing starts moving. What other forces acting?
Friction.
Friction. In which direction?
It's left.
Because tension is what starts pulling our entire system, and friction is always counteracting its cause, right? So that's that friction. So yeah, then we can go ahead and set up a couple of equations, and that's where the minus sign comes in. First block, right? We said gravity is acting. Yes, please.
I see that there's a net force downwards. Does this thing accelerate downwards?
It would, in principle, yes, but there's a table in the way, right? A good question. We come to that as soon as we're dealing with the actual magnitudes of the forces, right? So we're setting up the equilibrium for the first one, as we said. Gravity is pointing downwards. Tension is pulling us up, so we need a relative minus sign, right? That leads to an overall acceleration, right? By Newton's second law. How big is the magnitude of the acceleration?
Were we trying to say that there was
The magnitude Newton's second law. Sorry.
Oh, it's just MBA.
So that's all there is to it. It describes the motion of that block. There are two unknowns in it, so we would need another condition to solve it. And we do that by setting up the equilibrium for the second second system, right? So again, we have tension driving the entire thing. So tension pointing to the right. Is that right? Yes. Tension pointing to the right. And friction slowing it down, right? So we need an overall minus sign between these two. And here already Zelda's question comes in, because that frictional force that is slowing down our system is essentially driven by the normal force start pointing downwards, right? And everybody hasn't seen that formula. U times the normal force, right? Which again leads to the acceleration describing the motion of that part of the system. How do we include that? Again, Newton's second law, right? Which is?
MA plus MC
Yes?
A.
Okay, a little hard to see, but you said A. Are these two A's the same?
Well, they're kind of connected, right? So they're gonna.
Yeah, of course. I mean, if I'm pulling at that end, there's no reason that that block should move any faster or slower than with the speed I'm pulling down here. That is what the only task of the string, making sure that the entire system moves at both ends equally. So yeah, now we can go ahead and solve that. We're not really interested in the tension, right? So we eliminate the tension by, so if we arrange equation 1 to read T is mvg, just putting that on the other side and that over here. And plugging it into the second equation to eliminate T. Minus friction force, which was just the coefficient of friction times the normal force of the entire thing, and the normal force we already know as well. And that needs to be equal to MA plus MC times A. Which looks, is received, yes please.
So if we want to superglue a block onto MA so that it's not moving, why isn't A 0?
What?
Why do we still include A if we're looking to include block C? So
I mean,
that
what
it
we effectively do here is increase the mass of the block up here, right? So you're just making out of a small block, a system consistent of a small block, a system consistent of a big block. The fact that you superglue it is just so that you don't have any weird motion going on in between them. But the entire system is moving with the same acceleration. That block is accelerating with A just as that block is accelerating with A, because they are attached to the glue. Just as these two move at the same speed because they are attached to the row. That make kind of sense? Okay. So yeah, we can solve that, and I'm not, because I'm probably gonna get the three factors wrong. Just give you the solution for that. It's MA times G minus U times MVG divided by MA plus MB. And that is an intuitive result, because it tells me absolutely nothing but gravity is accelerating my system, the gravitational force acting on that block, while the frictional force acting on here slows me down, and the overall force is needed to accelerate the entire system, all three blocks. And I think sorry. And that is the interpretation behind that. There's nothing fundamental going on. It's just Newton's second law, applied over and over and over again. And yes, please.
Is that MVG?
Yeah. This
Right, makes sense.
catastrophe thing is right. But good for paying attention. So now we can finally answer the question, how big does the block have to be that we superglue onto the first block to find out when the whole system stops moving? What does have to happen? What does have to happen for that?
Acceleration goes to zero.
Acceleration goes to zero, right? So we can put that to zero and just solve for the mass of the third block. And that we answered the question. And we got the acceleration for free. Yes, please.
But zero acceleration would still mean a constant velocity, so it might still be moving.
That is true, but we assume that initially when we superglue the first block onto on top of the second block, the entire system is at rest. And then we let go of it, and since no acceleration is acting, there's no motion happening. But you're perfectly right. If it would have an initial velocity, it would continue moving, because the acceleration is zero doesn't mean the velocity has to be zero. But we take a hold of it.
So
to the
it's
root.
friction, yes. Okay, now I understand.
Okay? But you're perfectly right. If you just solve that condition, we just know that it would move at a uniform speed, which is not necessarily zero. Any other questions? Good.
Questions, comments for Daniel? What things he did well and what things he can improve upon?
It was very interactive. Yeah, that makes students pay attention. So that was nice.
Yeah, that was very nice. I think Daniel was really interacting a lot, and that I think is excellent, because this kind of an interaction will keep students' attention so that they actually pay attention to everything that he's discussing with them. So I think that was a really good thing. Other questions, comments, and things that he did well or can improve upon?
I think you have done
Sorry?
MA plus MP. MA mu, MA plus MP.
Yeah, I think it should be MC. That
yeah.
should be MC there. And also in the equation after that, there should be a G. There is a G missing after mu. Yeah.
Like that, right?
Mm-hmm. Other things that he can actually...
These are not mistakes, these are features.
Oh, please, Jim.
Yeah, whenever the first question arose about the net force being in the y direction, I think that could arise from the figure A, where there is no normal force drawn.
Yeah, see, I think what Sardar was asking earlier is that in that diagram that you have, you don't have a force acting upwards. And so I think, it would be a good idea to have your normal force shown in that second. See, the second free body diagram doesn't have the normal force shown. It only is showing the gravitational force acting down.
Yeah, you mean like the table pushing back.
Yeah.
Okay.
So that I think that's what he was asking you long time.
And actually that would be at least conception better to write it down, the friction force as mu F normal rather than Fg. Because it might confuse students that...
Okay, so I think I agree, and actually I would say that it's a very good idea to draw a coordinate axis, because I think it's very easy to confuse students. So I think it's a good idea to say, okay, let's choose the x-axis to be this way and y-axis to be that way, because I think that really puts everybody on the same, thing. So
Like just like
yeah, just call that x-axis and y-axis, so that way everybody is on the same page and everybody is trying to resolve the forces or do whatever with them in the same way. So I think that helps. And I think I also agree with Sardar that it is a good idea to actually, and I think somebody else asked this question too. I think, what was your question saying? What is the mass of MC so that the block just barely starts to accelerate? Something like that, right? Just
the
barely.
thing doesn't.
Yeah,
barely doesn't
so that it's
accelerate.
just, so I think because, he's saying you have to actually maybe explain to students that there is a critical place where the frictional force, the static frictional force, becomes maximum value, and that is the place where you have static frictional force equal to mu s times Fn, right? And Fn then in this case happens to be ma plus mc times g because of the fact that this is a flat surface, but it won't necessarily be if it was not flat. But the other thing is that I think students also need to understand that the frictional force is not always mu s times Fn. So the thing, that's the maximum value of the static frictional force. So in other words, I know that there are many problems in which the frictional force doesn't have that value, and students might just think that that's something that is given, so that's always the case. So I think you have to say that in this problem we are finding that critical value where the block is just about to move, so that means the static frictional force has become maximum. Because for all of the other cases it will be less, right? I mean, if it's not accelerating yet, then once, do you see what I'm saying?
Yeah,
so
yeah,
I think that's what he was trying to say. That's my guess. What other things he did well and what can he improve upon?
You didn't bring your stick, your teaching stick.
Yeah.
What is that?
No, I said I was used to teaching in Germany. He said he was doing it with the elbow patches.
Oh, I
And
see.
I said
I see.
in Germany we do that with a stick.
Oh, I see. No, I think Daniel's interaction was excellent, and I think that is something that everybody should learn from him. Because that is essential in order to keep students engaged, and he was always looking at the students, which is an excellent thing, because you don't want to be talking to the board. You really want to be looking at the students, so that's a very good thing. I think another thing, something that Fernando was getting confused about, instead of calling that A, that second thing there, call it A plus C. So I think because you are talking about like the total system A plus C, so you're talking about a combined system. I think the reason he was saying A is because you wrote A, right? Isn't that the reason you were?
Something like that.
I thought he was talking about the weight only of the lower block, not.
Yeah, and that's why I'm saying that maybe you should say that let's look at the system A plus C taken together, and then I think he would have answered, yeah. So I think that would make it clearer that
I was not blaming you.
No, no problem.
No, but I think it would make it clearer when you write A plus C, then they will know that that's the system for which you're trying to draw a free body diagram.
Yeah, maybe it would have. I mean, what I was initially going for was like call that system 1 and that